In a diagram that looks like this, it was not marked congruent, but what we can conclude is that because my radius and my chord are perpendicular, when that has happened, if a radius and chord are perpendicular, then the chord is bisected. The radius is not necessarily bisected, so we don't know that that's 1 and that's 1. I know that this segment and this segment are congruent. I need to use that because I want to find that entire segment UK. In order to do this, I can find this segment I've highlighted in orange first and double it to get the whole thing. What we have to understand here is the idea that all radii are congruent. This is a very big important theme so far in this chapter. I know that the radius of this circle is 13. And we also need to recognize that through any 2 points there is a line, so I can draw any radius I want. I can draw in the segment DK. When I do so, I know that that has a length of 13. So now I have one side of a right triangle. The second part is going to be finding this length here. Well, similarly, I know that from D all the way to the edge is 13 because that's a radius. And if this part's 1, this part here has to be 12. I now have a right triangle where I have two sides. Here comes Pythagorean theorem again. Legs squared plus, I don't know what this is, I'll call it x, legs squared equals hypotenuse squared. Go through the process of solving. 13 squared, subtract 12 squared, I get 25. X squared equals 25, which means that x is equal to 5. But x is not what I was solving for. I just found this orange segment. We know these two segments must be congruent because the radius is perpendicular to the chord. If x is 5, this segment's 5, and segment UK is 10.